maybe in English when you say that two things are similar, okay, we use it in a very loose manner. We just want to describe that things look alike. Okay? In fact, sometimes we may use the word similar when the things look the same. We also use the word similar. But in mathematics, there's a very precise definition. Okay? Congruent figures, we say that it must be same shape, same size. Okay? Similar figures, naturally, it of course must be same shape still. But the key difference between similarity and congruency is that it is no longer the same size. Okay? But I cannot say that it is different size also, because the idea of different size has a wide meaning. Okay? For example, it can be maybe like that. It's a triangle. Like that also triangle, right? Okay? But there's no similarity between them. Why? Because maybe this is your obtuse angle triangle, whereas this one will be isosceles triangle. Okay, so we need to be very precise about the idea of sizes. Okay, so instead of saying different size, we will say that the size is proportional. Okay, the size is proportional to each other. That means that we can have one that is smaller, one that is larger. But comparing the sides, the length of the sides itself, it must grow in the same scale factor. So if this one is going to be 1 cm, down here 2 cm. Okay, so let's say this is 1 cm and this is 2 cm. If let's say I tell you that this is 0.8 cm, what do you think this one must be? If I say that it must be proportional, it must be 1.6. Why? Because 1:2 is a doubling of the length of size. 0.8, when I double it, it will be 1.6 cm. And that is what we mean by proportionality. Okay? If down here is going to be, let's say, 0.7 cm, then this side will have to be 1.4 cm. Okay? So it must be proportional to each other. Okay? So mathematically, how we go about saying it is that the ratios of lengths of their corresponding sides are equal. Okay? Now, if you recall from congruent figures, we mentioned that we mentioned not just about the length of the sides, but we also mentioned about the angles, the sizes of the angles having to be equal. In similar figures, we also want to talk about the angles itself. Okay? Now, what do you think? If I have two figures that are proportional to each other, okay? If this were to be 2 times bigger than this, do you think it makes sense that the angle of this one is 2 times bigger than this one? Let's use our brain to think. Okay? The angle over here, should it actually be 2 times that of this? For example, if I tell you this is 30 degrees, do you think it makes sense that this is 60 degrees? Logically, what will be the reason why you say no immediately? Yes. Not 180 degrees anymore. Because we know that for triangle, be it whatever size of it, the interior angles must always end up with 180 degrees. Right? It doesn't make sense that over here, if the angles end up to be 180 degrees, just because it grows double in I were to tell you that two figures are similar, maybe I'll have to draw a better triangle. Okay, ABC is similar to PQR. When I phrase it this way, the vertices will still correspond. So your A will correspond to P, B will correspond to Q, and C will correspond to R. Right? Then earlier on I mentioned that there must be proportionality. So if let's say this is 4, 5, and 7, okay, and if down there were to be 8, okay, then by the idea of similar figures, this must be 10 and this must be 14. Because this side corresponds to this and the ratio is 1:2 and it's double. So therefore, now there must be double 5, double 7. Okay. We look at maybe practice now 6 first. Okay, looking at the diagram in your textbook is much better. Okay. In this question of practice now 6, question 1, we are told that triangle ABC is similar to PRQ. We want to find the values of the unknown, that is your X and your Y. Okay. Now, remember how I went through the question earlier on for congruent figures? I recommended to you, suggested to you that maybe you should draw the triangles or whatever figures that you have in a side-by-side manner such that they are of the same orientation, whereby the vertices are corresponding to each other. If you look carefully at the vertices given to you, we have A, B, C, but it is similar to PRQ. P is over here instead of on the left side, okay, that we see on the left figure. So my recommendation to you, if you don't want to have such a heavy load in terms of interpreting a diagram, redraw a triangle PRQ with something that looks similar to ABC, just that it has to be of a smaller size. The accuracy of the drawing doesn't matter because it's meant to help you as a guide. So I have ABC, now I have PRQ. I just have to transfer the information now. X degrees is at P. QP is 4 cm, P is here. QR is 2.8, so 8 cm. But of course, I'm not going to make it compulsory for you to redraw the diagram. Okay? If you are competent enough to be able to see it very clearly and easily, by all means continue. Okay? But I know some of us are challenged in terms of geometry visualization. So this is my recommendation. Right? Now that we have it in a side-by-side manner, comparing this one and this one, okay, are we able to immediately tell what is X degree? Let's select someone. Vision. Xavier, okay. Yes, Xavier. Can you tell me what is X degrees? You'll be 30 degrees, right? Okay. Yes, let's see. Next. What about YCM? What is YCM? Kyra, what do you think? Okay, sorry, Kyra and the last person standing. Yes, Joan. What is Okay, definitely not 2.8. So remember what I said over here. The ratios of lengths of their corresponding sides are equal. In this case, it is not as straightforward as just doubling. The scale factor is not 2. Down here we have 6 and 4. Okay, that is actually corresponding to each other. So we can get a hint out of this 6 cm and 4 cm over here. How do we present our answer? That is the problem. Okay, y is what I want to find. We're talking about the ratios being equal. Okay, when I use the word ratio, I don't always mean that it must be the one with the 2 dots. Okay, ratio is an interchangeable term about fractions as well. Okay, so y is corresponding to 2.8. I will write it as y over 2.8. Okay, then it is actually equal to the ratio of another pair that I can find. And I see that in the first triangle, I have 6 cm versus 4 cm. So I form my statement in this manner. Something that I want us to pay attention to is that y and 6, the things in the numerator, are from the same triangle ABC. And then the things in the denominator are also from the same triangle, PQR. Right? You cannot have different triangles values on the numerator or denominator. Okay, cannot be switched the other way around. So on the numerator, they must all come from the same triangle. Denominator must come from the same triangle. Okay, so I will express my answer in this manner. Y over 2.8 equals to 6 over 4. So to find out the value of y, don't bother about trying to cross multiply via hassle. It's just taking this 2.8 multiply over, and then you can find y already, right? So 6 over 4 times 2.8. Okay? And that will give us 4.4. So the challenge that Joan faced just now, okay, trying to determine times what value, okay, is because she didn't write it all down. So I would recommend that you write things down properly rather than trying to figure out mentally. Because you don't want to end up giving me maybe times 2 over 3 instead of actually 3 over 2. Because 6 over 4 is 3. Okay, so form the equation relating the corresponding sides, the ratios of the corresponding sides, then after that go about calculating. So within that ratio itself, within that fraction,